Hi everyone, welcome back to my YouTube channel. So today I'm going to do a simple video on how we can load different models in Hugging Face. So often when we are getting started with NLP, Hugging Face is actually a good point where we can try out different pre-trained models which other industrial experts have actually built and to understand how we can actually utilize or fine tune in our use case. So today we are going to do or today we are going to load different set of Hugging Face models and see how we can actually incorporate in our code. So let's get started. So before that, I would like to quickly explain the Hugging Face model page. So this is the model page where you can actually see different tasks and the corresponding models are actually listed here. So for example, if you want to get the models for text classification, then go to text classification and you can actually see the different text classification models here. Similarly for text generation, then summarization, so different models are actually available. So let's get started and try to understand how we can load these models onto our workspace and work on it. So first of all, I would like to explain about the token classification or the named entity recognition models. So before that, I think like you guys need to install the transformers library. So like if you haven't installed, then it's actually a simple command. It is nothing but pip install transformers, and with that library, then you'll be able to kind of load all these packages into your workspace. So first of all, on the token classification part, so let's go to the model section and understand where the token classification is there or the named entity recognition. So this is the named entity recognition page, and you can actually see different models and different variety of models are actually present here. So let's look at this particular model, which is very popular, XLM Robot Large Fine Tuned, which is fine tuned on Corn LL03, which is the predefined data set for NER task. And like there is no model card, but like the downloads is pretty much, that means like the model is pretty good. So if you can just hit compute, then you'll be able to see, and you can actually try out different examples here. Now how we can load this particular model onto your workspace, or how you can actually leverage this particular robota model. So for that, let's first import auto tokenizer and auto model for token classification object. So basically these two uh, functions are actually required to load this uh, token classification model, and these kind of things are actually detailed in this pipeline document basically. So pipeline object is kind of like a very interesting one in Hugging Face, where we can, so it's more kind of like a simple API to kind of specifying all the task, or like all the tasks can be specified in this particular pipeline easily. So for example, these are the list of tasks which is actually being specified in this particular pipeline. So for example, let's take okay, token classification pipeline. So if we hit token classification pipeline, then that corresponding document is being there. So this is actually the uh, documentation for it. So you can actually see like which all variables or arguments you can actually pass it, and try to understand how it's being done. Like these are some of the entities. So likewise for each of the task, a model specific task, there is actually a pipeline object. Now um, so we need to load auto tokenizer and auto model token classification, and as I mentioned, we need to load pipeline. Okay, so these are some of the important parts, and now it's time to load the model part. So I was talking about these models. So this is a model called XLM Robot Large Fine Tune. So we can load this model, as well as there are other models available. So BERT Large Case Fine Tune. So in this tutorial, I've actually loaded this particular model. You can use any model of your wish basically, based on your computation or the purpose which you are serving, and even the use case, because some of these models have entities, general entities, but some of these other models are actually trained on very specific entities. So you need to actually try it out in this model card, which entity you need to have. Also the accuracy part, so you need to benchmark how good the accuracy is basically for each of these models. So once you've done that, you can actually choose the best model which you like. So in this case, I'm actually choosing this particular model, and then I'm giving the same for tokenizer and model. So here I'm actually using auto tokenizer and auto model for token classification. So this is more kind of like a generic one. You can even use the specific TensorFlow version as well as PyTorch version. But that's not what I'm discussing today. You can actually use this generalized version for now. And then the next one is the pipeline object creation. So in the pipeline, we are specifying what is the task. It is NER very clearly. And then model, we are actually declaring this as the model and tokenizer. And then an argument called grouped entity is equal to true. Why? Because what happens if we don't specify this group entity is equal to true? So often cases, what happens is whenever an NER is actually being predicted, or it is actually being specifying the data, what happens is sometimes it will actually given, or it will actually pick up the tokens basically, and the rest of the tokens will be hash hash. So we should not, we don't want, in an output perspective, we cannot actually afford that. So to combine or to club all these entities together, we actually use this group entities equal to true argument here. So once that is specified, there is a simple function which I have written for for actually the purpose of running this particular pipeline. So def extract ends. So this is the function which I have written. So it is nothing but NER results equal to NLP of send. So this is NLP, and we are specifying what is the sentence or the paragraph which you are giving. Then we are looping through this NER result, because NER result will be kind of like a group value. And once the entity group equal to person, so in this case I am extracting person as the entity, and that depends on particular use case which you have. Suppose you need to extract location, then you need to give LOC. If you have to extract MISC, then you need to give MISC. So it is purely based on your requirement or organization, whatever you need to extract. And once that is done, then you will get the entity which is being extracted. So this is the function. And now let's see what is a simple example usage against a particular sentence. So using this particular function, it is pretty easy. You just have to write the sentence inside this extract ends function, and then the it is actually returning the list of names or list of whatever you defined here. You will be actually able to extract. So this is a simple function which does that. Also, this same function can be used to execute on a batch or a data frame column. So for that, you have to load a data set. So in this particular thing, you can see some sentences, and this sentences I am actually applying through a lambda function here. So data sentences dot apply, and I'm specifying a lambda function here. So lambda x is to extract ends. So extract ends of x. So basically my lambda, my dynamic lambda function is actually being declared here with extract ends of x. So each row is considered to be like passing into this particular function, and it is being executed in what to say, row wise basically. So that is the beauty of this apply function. And with that, with this single line, you will be able to kind of get the entity list. So that with these two steps, like you will be able to kind of extract whatever entities which you need in a batch. So that's how you will be able to kind of work with auto token classification or named entity recognition problem. So the second task which we are going to look today is the text classification problem. So for text classification, we need to import auto tokenizer as well as auto model for sequence classification. So this is the particular function for it. And then we need to specify the model just like how we specified before. So here I'm actually taking Distilbert base uncase fine-tuned SST2 English. So you can go on and try to understand which classification model you need. So here there are so many varieties of classification model, and that purely it's depend on your purpose. So let's say you need to predict for sentiment classification, then you need to try out some sentiment classification model. Or you, if you need to predict for some other classification, you can actually look at like if there is any other classification which is matching for your use case. So it purely depends on what you need and what use case you are actually working. So once you identified that, similarly how you loaded for token classification, so here you can actually load for text classification problem also. So tokenizer and model you are specifying. Once that is done, again you can define the pipeline object. So here the pipeline object is nothing but text classification. So earlier it is NER and now it is text classification. And one more thing which I forgot to mention earlier is, so whenever you are working on these kind of models, it's always advisable you work on a GPU cluster. Why? Because for demonstration purpose, it's easy to showcase one or two examples using these kind of pipeline or the transformers library. But in a production runtime operations, it is always good to use in a CUDA environment. Or if you are running on a batch of files, it is always good to run CUDA equal to 0, so that you can just specify the values equal just like this. So CUDA equal to 0, if you specify like this, then it will take it from there. It will be running on the GPU cluster. So once that is done, you can simply call out for a single sentence. Like you can add the single sentence here, and then you can just run the classifier object. Then you will be able to get the classy out. So basically, classy out is nothing but here it is a list of dictionary with one of the dictionary uh, key is label and another key is score. So you will be having the values as whatever it is getting predicted. To simply subset it, you can just write. So this is the first element, so it's the index 0 and label. You will get the value of the first key, and this is for the second key. So this is how you run it for a single sentence. And now let's see how you can run it for a bulk or data frame. So we will take the same case like the sentences which we have seen earlier. In this example, it is pretty simple. It's just that you just have to apply on top of this particular classifier x function. So lambda function, and we are specifying classifier of x inside the apply function. So it is straightforward, and within just one line, then you'll be able to get this output. And in this output, the crucial part is it is still be available as list of dictionary format. So once if you have to split it, then you need to add these two lines. So I advise like no need to split during the runtime. Why? Because it is simply running the model, and it can actually cost you a good compute. So once it is done, then it is pretty straightforward, because this will take little time to run, but this function will not take time to run, because it is simply we are just specifying x of 0 of label, and we are getting the classification label as well as a classification score. So this is how you run the text classification pipeline for a bulk of data. And now let's see how you can run it on a zero-shot classification problem. So zero-shot classification problems are right now so important, because most of the time we are facing issues with the, like, we are in scarce of data. So there are so many pre-trained models available in the zero-shot classification. So zero-shot classification, what it does is, so let's take one of the model by Facebook. So it is pretty straightforward. If we have a data like this, and if we can specify some labels, then the best part is these sentences will be automatically classified, or there will be a probability score against each of these classes. And this is purely pre-trained on some other data which we may not be having any visibility, but uh, I suggest you guys should try it out before working on any of the problems, because in some cases it can work, but some cases it will not work based on the use cases. So if it's some generic use case, I always advise you guys to try out zero shot classification. And here they have mentioned how to load a shot classification problem model. So it is simply classifier, we can specify the pipeline, and in the pipeline it is simply zero shot classification. And here we can specify the model as well. So there are so many models available. This is a very huge model. If you cannot afford this huge model, then it is always good to try out some simple models. So there are tiny versions of, or Distilbert or Robota, small versions basically available. So that also you can actually try it out, because most of the cases it will be very large and it will be too much time consuming, and it can merely increase some very small amount of accuracy. So in this case it is pretty straightforward. We just have to specify the sequence to classify. So it is a predefined example in the Huggingface. So it is just we have to specify the sentence and what are the labels ideally. So if we just run it, then we will get we'll get the output in a dictionary format. So as a key value pair. So in the score section, you can clearly see this sentence is having 0.99 score for travel. Dancing it is 0.003, which is pretty low. 0.002 for cooking. So this example is pretty good, I would say. And you can even execute on a batch or a data frame, just like how we have seen earlier. So for that, you first need to specify the candidate labels. So in my problem, it is mainly about Marvel data store, where it is talking about Thor, Loki, and other comic characters. So I have defined a class called comics, then a class called nature, and then a class called warrior. So these are the three classes which I specified. So data of zero shot classification equal to, I'm just specifying the sentences, and here inside the classifier object function, you need to specify what is the labels basically. So if you specify these labels, then this is it, and it will actually give you the sequence. And just like how you have subsetted in the other examples, you can even try out filtering or get rid of this dictionary structure by splitting it into whatever data format, just like how you have seen in these kind of examples. So you can apply a lambda function and just give the split like this, and with that you'll be able to get the output. So this is the last topic for today, and it is question answering. So question answering is a very important NLP use case where it is very difficult to first of all build a question answering, because we need huge amount of data, and that data should be annotated in a very particular format. Compared to the other language task, it is pretty difficult. And for that, like, there are so many pre-trained question answering models available, and which is often pretty good in terms of performance. So before training or before getting started to train a question answering, I always suggest you guys to try out some models which is already available, which can serve the purpose. Not sure, but always it's good to try it out. So, just like how we have done earlier, we need to specify the question answering model here. So, you can take any model here, it's up to you. So, this is one of, yeah, this is a good model actually, but it is pretty large. So, in this example, I have taken a very small model, Distilbert base case, and this is specified for question answering. Then we need to specify the model name and tokenizer name, and with this pretty simple command, it is possible to kind of work through. So here you need to give the question, and in this dictionary format, so qa input equal to, in this dictionary format you need to give question, and what is the question which you need to ask, and what is the context. So context, inside context you can give the sentence or paragraph which you feel like. And this is for one example, and the output will be, we'll be getting the output by just running NLP of QA input. So NLP is nothing but the pipeline object of question answering, which is specified for that corresponding model. And now this res is nothing but we get the score, we get the starting index, and we get the ending index, which is very important. So oftentimes we need to locate where the data is there. So we get that information, as well as what is the portion of answer which the model feel like for this particular question. And now, so often cases we cannot actually clearly specify it in as a context like this, but we need to kind of give it as a whole bunch of context in a data frame or a list of sentences. So for that, always this is actually a good format. So this is nothing but the series or the data frame column, data of sentences, and converting that into a series, sorry, list object here, and then I'm joining with dot. So it is nothing but this whole thing is now become a string, just like how you see in this particular example. So once again, it is this is a data frame data which contains the Marvel data, and I am specifying the column called sentences, which has the sentences of Marvel characters. Now I am converting that series into a list, and then finally I am joining everything into a string with dot separated, dot space separated. So once that is done, then you will be getting. So when I ask who is Thor, then it returned me as father, but it is wrong. So, but yeah, when I tried the other model, that means I think this Robota based code, it was giving me the result as properly. So this happens, and what is Thor's weapon? It gave me the good result, Stormbreaker. So either it can give more Mjolnir or Stormbreaker, but yeah, it gave me Stormbreaker. So this is how we can actually specify it on a batch of sentences or a data frame for a question answering problem. So with this, we are winding up today's NLP tutorial. So I'll be doing another part for extending this Hugging Face tutorial. So please leave me a comment what all topics you would like to see in the next tutorial, and even I'll be extending this to fine tuning different BERT models or different other Hugging Face models for the specific problems. So thanks a lot guys for watching this video. Have a great day.